Want to introduce the technique or method of Gaussian elimination. Okay, Gaussian elimination is a popular and reliable technique for solving systems of linear equations. Let's go ahead and recall that an equation is linear if and only if every term in the equation is a monomial of degree 1 or possibly a constant. Okay, a system of equations is a set of two or more equations. A solution to a system of equations is a set of values for the variables that satisfy all the equations. Okay, let's take some examples here. The equation 2x minus 3y equals 7 is linear because all the terms are constants or monomials of degree 1. This term is what? A monomial of degree 1, right? Same thing here. That's a monomial of degree 1. 7 is just a constant, so this is a linear equation. Okay? If you actually graph this in the xy plane, it would be what? And actually, a line would be the graph. This second equation here, x, that's of degree 1, but oops, this second term here is of degree 2, isn't it? Okay? And the fact is, this is a constant term, doesn't help here. The fact that this term is not of degree 1 or a constant makes it non-linear or not linear here. Okay? And then the last one is this system here. 2x minus 7y equals negative 3. X plus 6y equals 8. This would be a linear system here. Those are both linear equations, as you can see. Okay? And what would be a solution to this system would be x equals 2, y equals 1, because if I try to substitute those values into the equation, I get 2 times 2 minus 7 times 1 is negative 3, question mark, and that's true, okay? And 2 plus 6 times 1 equals 8. That would be another question mark, and that would be true also. So x equals 2, y equals 1 satisfies both equations. So we would say x equals 2, y equals 1 is a solution to this system of linear equations. Okay? Now, the first major step in Gaussian elimination is setting up what we call the augmented matrix of the system. This matrix consists of all the essential features of the system in the form of an array of constants of the system, these being the coefficients and the constant terms involved. In order to form the augmented matrix, a couple of minor steps must first be taken to put each of the equations in the linear system in their proper form. First thing, you want to write each equation in the system with the variable terms on the left-hand side of the equal sign and the constant terms on the right-hand side. And creating any order you wish on the variables, often we'll just use alphabetical order or subscripted variables in their natural order, and then write each equation with the variable terms in that order. Let's take a couple examples here. If you guys look at this system, this is actually what? A system of linear equations. 2x minus 5 equals 11y. Y plus x equals 13 here. Now, it's first thing that's violated here, you guys notice the constant term here is not, in the first equation, is not on the right-hand side of the equal sign. And also this term, this first degree term or linear term involving y is not on the left-hand side of the equal sign, but we can easily move them over this way. I'll imagine adding 5 on each side of that equation. Simultaneously, I'll subtract 11y on each side, and we will get 2x minus 11y is equal to 5. That's for the first equation. We just rewrote it here. Now, the second equation is actually satisfies the first condition here, but you guys notice here, in the first equation, I've got x's then y's, but in the second equation, I've got y's then x's, reading from left to right, of course, like usual. What I'm going to do is write these both in alphabetical order with x's before y's, so the second equation becomes x plus y equals 13, Now, this is an equivalent system of equations, right? Linear equations, but this time they would be in what we would call the proper order because we actually have these two conditions satisfied up here. Okay? Alrighty. Alrighty. Let's try another example here. We've got x minus z plus 4y equals negative 9, y plus z minus x equals 2. So let's take a second here and see if you can rewrite this in its proper form here. Okay. I'll give you guys a second here. Okay. Well, as far as the proper form goes, you guys notice condition 1 here. Write each equation in the system with the variable terms on the left-hand side of the equal sign and constants on the right-hand side. That is actually satisfied here, but we've just got a jumbled order in the variables here so that number 2 isn't satisfied here. Now what I'm going to do is have the natural alphabetical order for my variables x, y, and z here. So what I'm going to do is rewrite each equation in the order x, y, z. So the first equation is going to be rewritten this way: x plus 4y minus z equals negative 9. Okay. And the second equation I'm going to write this way. Let's have it negative x plus y plus z equals 2. Okay. So before even creating what we call this augmented matrix for Gaussian elimination, you do need to make sure your linear equations are in what I call proper form here. Okay, that should be pretty simple, and most of the time we will be giving you equations in that form automatically for problems to solve, but it's just something to be aware of here. Alrighty? All right. Let's go on to the augmented matrix.